So here I'm going to wrap up section 10.6. I'm going to actually talk about this out of order ever so slightly. Here in the second box, I have the different techniques and tests that we've gone over so far for determining whether a series is convergent or divergent. So here they just kind of are summarized in one place. But I want to finish out this section. We're going to look at what's called the rearrangement theorem for absolutely convergent series. And it says, if series A sub n converges absolutely, and B1, B2 through Bn is any arrangement of the sequence, then B sub n also converges absolutely, and their sums are equal. So I'm going to show you how this theorem can work in practice. So I'm going to look down here. This is going to be our last example. It says the series 1/3 minus 1/2 plus 1/9 minus 1/4 plus 1/27 minus 1/8, etc., fails to meet one of the conditions of theorem 15, which is the alternating series test. Which condition does it fail to meet? Well, if you look, we have 1/3 and then 1/2, then 1/9, then 1/4. These terms are not non-increasing, okay? So it fails to meet the second condition. Because you can see the terms increase, then decrease, then increase, then decrease. And I'm not even taking into account the negative signs. So what can we do here? Well, we can use that rearrangement theorem, which is at the top of the page here, and rewrite this. So I'm going to rewrite the series, and you maybe can see where this one is going. I'm going to rewrite it as such. I'm going to write it as 1/3 plus 1/9 plus 1/27 plus, dot, 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 plus 1/3 to the n. And I've got a slight typo here. Technically, this should continue on, or you could just even keep going with this. Then I've got a minus, okay, and then a parenthesis. So I'm going to turn all my terms inside the parenthesis positive. So we've got 1/2 now, plus 1/4, plus 1/8, all the way to 1/2 to the n, and continuing. Now, these are both geometric series. We now have two geometric series. So what I've got for the first one is the geometric series from n equals 0 to infinity. And this would be 1/3 times 1/3 to the n minus 1. So that first 1/3 is the a value. The second 1/3 is the r value. Since 1/3 is less than 1, we know that this converges, and we also know the sum. And then over here, I've got a second geometric series. This one is going to be 1/2 times 1/2 to the n minus 1. Or sorry, it's 1/2 times 1/2 to the n. I started them at 0. Sorry about that. So in both cases, we have an a value and we have an r value. And in both cases, that r value is less than 1, so we know that both of these converge, and we know the sum. The sum of a geometric series is going to be a over 1 minus r. So I can use that for both of these. So the first one, it's going to be 1/3 over 1 minus 1/3, then minus. Then over here, it's going to be 1/2 over 1 minus 1/2. So 1/3 over 1 minus 1/3, that's 1/3 divided by 2/3. And 1/3 divided by 2/3 is just 1/2. Here I've got 1/2 divided by 1/2. Well, 1/2 divided by itself is 1. So we have a sum of 1/2 minus 1, so the sum is negative 1/2. That's where that rearrangement theorem can come in handy.